So I'm here to talk about the serological response to feline coronavirus and cross-reactivity between feline coronavirus and SARS-CoV-2. So as I'm sure many of you know, feline coronavirus is a ubiquitous virus of cats that was isolated in 1976 and causes usually subclinical to mild enteric disease with a seroprevalence of between 80 to 95% worldwide. And I mean, although most cases are subclinical, around 10% of cases lead to the development of feline infectious peritonitis, or FIP, which until the recent introduction of antivirals has been a fatal disease of cats. So as you can see on the left, the virus has the general structure of coronaviruses and can be classified into two serotypes, type 1 and type 2, type 2 being a recombinant between type 1 and canine coronavirus. And within these two serotypes, we can group infections to two pathotypes, feline enteric coronavirus and feline infectious peritonitis virus, this latter being the causative agent of FIP. So recently there has been an outbreak of feline coronavirus on Cyprus, which you'll hear a lot more about later on today. So just to give a brief overview, in 2023, a novel highly pathogenic strain of FCoV emerged on Cyprus, causing a 40-fold increase in FIP cases, which kind of highlighted the importance of investigating the prevalence of these infections, not just for future preventative measures, but also to gain a deeper understanding of the virus itself and infections that it causes. So for this reason, the aims of my research are to investigate the serological response to FCoV in the UK domestic cat population, and through this compare cross-neutralization between antibodies to FCoV type 2 strains. And additionally, as we know that FCoV and SARS-CoV-2 co-circulate in the cat population, we think it's important to understand the impact that the two viruses have on each other and potentials for cross-reactivity, but also recombination between these two viruses. So I'm also working on exploring the potential for cross-neutralization and cross-reactivity between FCoV and SARS-CoV-2 antibodies. So to do this, I carried out pseudotype virus neutralization assays and Western blotting. And I'm going to give you a brief overview of this first one. So pseudotype virus neutralization assays were used to investigate the seroprevalence of FCoV in the population. And this was done by constructing pseudoviruses with a HIV core that contain the luciferase gene and express FCoV spikes on their surface. So as you can see, in positive samples, FCoV neutralizing antibodies are present, so viral entry is prevented, whereas in negative samples, these antibodies aren't present, allowing viral entry and luciferase expression, and this expression is what we measure. So overall, we've tested just a little over 1,100 samples, which you can see the distribution of on this map, and which clustered around Glasgow, Blackpool, and London, Greater London area. And these are residual serum samples submitted for other testing purposes at the University of Glasgow's Veterinary Diagnostic Services. So just to give a bit more background on the samples, these were broken down by risk factor groups, which were sex, age, and breed. And as you can see, the sample population was slightly skewed towards a younger male population, with domestic short hairs being the most frequent breed for pedigree or non-pedigree cats, and Maine Coons being the most prevalent for pedigree breeds. So when looking at seroprevalence, we found an overall 13.6% FCoV neutralizing antibody seroprevalence in the tested population, which was similar within both strains that we tested for, which were FIPV 79146 and FIPV DF2. And furthermore, we broken this seroprevalence results down to risk factor groups and found no difference in seroprevalence when looking between sex, age, and breed groups, which suggests that these variables had no impact on the infections. These results also allowed us to compare neutralizing antibody strength within these strains, or to these strains, which you can see on the graph over there, which compares the 2 strains we tested for and contains the titers of seropositive samples. So as you can see, we found a close correlation between the 2 titers, or 2 strains tested, suggesting that these strains cross-neutralize with each other and offer cross-protection, well, infection with one of them. To break this further down, we took the highest titer of each sample to compare titers within risk factor groups, and we found no variation in the neutralizing antibody titers to FCoV within sex, breed, and age groups. However, as you can see with age groups, results are approaching significance, especially when we compare the kitten junior to the mature group, which suggests that increasing our sample size could kind of enlighten that maybe there are differences between these groups. So the population that we tested was a smaller subset from a bigger sample group that has been tested for SARS-CoV-2 seroprevalence, and you'll hear about this later on today. But this allowed us to investigate the SARS-CoV-2 status of FCoV seropositive samples in the population, and this showed that these samples had a range of neutralizing antibody titers for FCoV, or SARS-CoV-2, which you can see in this graph with SARS-CoV-2 being on the y-axis and FCoV being on the left. This highlighted that there was no evidence for cross-reactivity between the samples. Unlike when we compared the 2 FCoV-2 strains, we've seen no correlation between the titers when comparing the 2 viruses, which suggests that there's not really cross-protection offered by infection of one against the other. Additionally, as you can see, some of the dots are highlighted in red. These were samples that had a second positive FCoV test done by the University of Glasgow's VDS, which highlighted that not all samples that test positive for FCoV neutralize, as the 4 samples in the negative for all group did test positive via non-neutralizing antibodies test. So to investigate this further and to look into cross-reactivity for SARS-CoV-2 further, we carried out Western blots, which we've done by running purified virus on a membrane and then cutting this into strips to test individual serum samples. So there were 3 groups of serum samples tested. These were FCoV non-neutralizing, FCoV neutralizing, and SARS-CoV-2 neutralizing positive samples on both an FCoV-2 and an FCoV-1 membrane, so against both serotypes. Through this, we found that both FCoV neutralizing and non-neutralizing positives reacted similarly on Western blots. And additionally, we've seen no evidence for cross-reactivity between FCoV and SARS-CoV-2, which is evident with there being no banding in the last 2 lanes on both membranes that represent the SARS-CoV-2 positive samples. So this again showed that we see no evidence for cross-protection between these 2 viruses. So just to summarize, overall we found the 13.6% FCoV neutralizing antibody seroprevalence in the population. Now it's important to note that these samples have been tested for serotype 2 strains, whereas in the UK serotype 1 is the circulating serotype, so seroprevalence is likely to be higher slightly, and we are planning to investigate this in the future. Additionally, we found no difference in FCoV neutralizing antibody titers between risk factor groups. Neutralizing and non-neutralizing positives reacted similarly on Western blots. And finally, we've found no evidence for cross-reactivity between FCoV types 1 and type 2 and SARS-CoV-2. So, yeah. And with that, I'd like to thank you for listening, and thank you for everyone who
thank you very much.
Yeah.
Do we have any question from the audience?
Is it on? Hello. I have one question. It might be a very stupid question, but the non-cross-reactivity between FCoV and feline coronavirus and SARS-CoV-2, is it expected? Like, how similar are the structural proteins between these two viruses? Would we expect some level of cross-reactivity? And
So, according to research that I've looked at, there has been suggestions of cross-reactivity between alpha and beta coronaviruses, and there has been a study that suggested some levels of cross-reactivity between FCoV type 1 and SARS-CoV-2, which found no cross-reactivity with FCoV type 2. So I did expect to see some, but yeah, we haven't really seen any.
If I can add on this one, maybe. Do you believe that this cross-reactivity might be related more to non-neutralizing antibodies? Just because the similarities and the spike is very low at that level.
Yeah, it could be. That is why we've carried out the Western blot assays to see if there was any cross-reactivity with maybe the nucleoprotein. We haven't seen one, but maybe increasing the sample size that we test for this could shed light on more.
Yeah, another one.
Very nice talk. What's known about the receptor usage for these viruses?
So for type 2, we know that feline aminopeptidase N is the receptor. For type 1 viruses, the receptor is unknown, which is why it's quite hard to test for it in cell culture or in serology. But yeah, we would like to do this like that in the future. Yeah, currently on it.
Yeah, because you could use your pseudotypes to actually identify the receptor as well.
Yeah, we have a last one.
Hi, great talk. I was just wondering if you had any, from the cats that you were sampling, if there were any human companion metadata that might have suggested like SARS-CoV-2 exposure that then you could guide your testing by?
I do have metadata on this, however it's quite hard to figure out which cats came from a shelter and which cats came from just homes.
Yeah.
I am planning to analyse that in the future. I haven't had the chance to yet.
Cool.
If there isn't any other question, maybe I'll squeeze in.